What we want to do today is take a first look as if you had never looked into a computer. Many of you have, so this will be very basic for some of you, but when you open a machine up and look inside of it, what do we actually see? So the first look at the parts, and then a little bit of discussion about some tools. So the objectives are learn about the various parts inside the computer case and how they connect together and are compatible, because if the parts aren't compatible, it's just simply not going to work. It's kind of like buying a Mercedes part for a Yugo. It's probably not going to fit. It's gotten a lot better over the years as we've come around to standardization, and standardization allows many manufacturers to make the same part, which will fit into a computer. If you do auto repair and you go to a parts store, you can get, in many cases, universal parts that'll fit various automobiles. Not exactly the ideal thing to have, but it functions. Although in this case, these guys are built to a standard, so they should work as well as something provided by the manufacturer. However, you do need to be sure that you do have compatibility. How to protect yourself and the equipment against the dangers of electricity when working inside the case. One of the biggest hazards in the computer repair world is static electricity. We've all probably shoveled across a rug and touched a metal doorknob and gotten a nice little arc and spark. These things, I think, they say go up to 50,000 volts. A computer part can be damaged by static electricity that you can't feel. So you really need to be very careful about how and when and where you work and how you're configured, you yourself are configured. What we want to do, what we'll talk about, is using a wristband or an ankle bracelet or a mat to make you at the same electrical potential as the computer itself. The tools you'll need as a PC hardware technician, safety precautions when working around the computer equipment. Tools, yes, we need some, but you really don't need that many. A number of pieces of test equipment are handy to have. To take a computer apart, you can basically take it apart, in most cases, with a Phillips screwdriver. What's inside the case? The case, sometimes called the chassis, and it holds the power supply to provide power to the motherboard. The motherboard, the principal board on the machine, and the thing that contains all of the everything else, all of the important components that make the computer work. The processor, memory module, expansion cards, and as computers become more and more, I guess, advanced, at least as the motherboards become more and more complete, we get into a situation that we really don't use as many expansion cards. If you look at the older machines and looked at the back panel, almost everything was with an expansion card. If you look at a new machine and look at the back panel, almost everything is built onto the motherboard. Hazard there is, what if the component dies on the motherboard? We'll have to go into the BIOS and disable it and then use an expansion card. You need to look at how many and what kind of expansion slots that you have in a machine, because they're all going to be a little bit different, and you need to buy a machine that has what you need to have. It holds the hard drive, and now the hard drive we would also consider a solid state device, optical drive, CD, DVD drive, and other drives if we had perhaps a floppy, which you're probably not going to see, or maybe a tape module or something like that would be in there. Different kinds of cases. A tower case sits upright, can hold several drives. Desktop lies flat, sometimes holds a monitor, sometimes we have the one pieces. The laptop case, the mobile that we move around from location to location, an all-in-one case is used with an all-in-one computer. A number of those are on the market today. I've always thought the hazard to that would be if the monitor quit, then you've got to go basically buy a whole new machine. The new ones are not the first time that there have been all-in-one cases, but they've gotten much, much better. Take up a lot less space on the desktop, and when you're buying these things, when you're looking at doing something for a company, that may be one of the considerations. Aesthetics could be one of the considerations. You don't want stuff on the floor. Keep in mind that if you put these things on the floor, in many areas, carpeted areas in particular, you're going to make the machine dirtier quicker, which means more cleaning, because what the dirt's going to do is prevent the fans and all of the stuff working inside the machine from working properly, as well as insulating it and causing a heat situation. These images, and if you really want to take a look at them, you can pause and read about them, are different plug-in components that would go on a machine. Frequently are going to appear as part of the motherboard, maybe part of an expansion slot. As we go up here, the VGA, a number of these things probably going to be asked about. A VGA port in this thing, you notice that it is 3 rows of 15 pins, and they're typically going to be blue today. On this video port, a 4-pin or a 7-pin round port used to connect to a television or other device. A DVI, digital video interface, transmits digital and analog video. And these are ones that you may see different ones. We're going to have a digital only, we're going to have a digital and an analog, and here are the analog pins for this one. An HDMI is an all-in-one, transmits the video and audio, not analog transmissions, often used to connect to home theater equipment. Also may be used to connect your tuner for your cable or satellite TV to the television, may be used to connect your computer to a television. You only need one cable. You don't need a separate audio and video cable for these. Display part, this one is relatively new, and it's supposed to replace all of these things up here to connect the monitors to the machines. Thunderbolt transmits both video and data on the same port, and then a network port, RJ45. We have RJ45 and RJ11. RJ45 is network, which is going to be 8 wires, 4 pair. RJ11 for telephone is going to be 4 wires, or 2 pair. Continuing, a system usually has 3 or more audio ports here in this thing, and each of these is going to be, they are color-coded as to what's what. We have our speaker here, our mic here, gaming port here, as we go down the system. Sony Philips digital interface and sound port, you may or may not see those. USB you're going to see, and the USB original, USB 2, USB 3, all are going to look alike. They have different speeds. The USB 3 is significantly faster than USB 2. Firewire, IEEE 1394 port, you may or may not have. These are kind of falling out of favor, although they still may be available, but you may or may not see those. The external eSATA, used to connect an external hard drive. So there's external SATA, the old PS2 ports for keyboard and mouse, and the machines that we're using where I'm doing this have these ports available, but we're not using them. We're using the USB keyboard and mouse, so these show up as having driver errors when we look into the system itself. An older serial port, and you notice it has 2 pins, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is something that you may or may not see in today's world, and if you do Cisco maintenance, this is something that if you don't see may or may not cause you some issues because when you try to connect to the console port, you need a serial connection to do it. So you may have to go back and do something like a USB to serial in order to do these types of things. Parallel port, in this one, the parallel port, 25-pin female. Older printers will use this type of port. And a modem port, the RJ11 is smaller than the RJ45. We actually here have the RJ45 and the RJ11 side by side, so you can see kind of the difference in the size of these things. When we look, take the side panel off of the case, a number of things are immediately visible. The first here is going to be the power supply. When we get into power supplies, be careful. Power supplies have capacitors in them. Capacitors store electricity. These things can be dangerous. They're not repairable. They're considered a field replaceable unit, and you'll see it abbreviated as FRU. You take it out, throw it away, put the new one in. The optical drive or CD here, we're looking at the back side of it. Back here is in the case itself, and here are the screws that would hold it in place. Power cords from the power supply to the different components of the machine. Let me see if I can get a different color pen here. Let's go with blue, because we have red here. The components here, if we go down and around and around and around, we connect into the motherboard. This is going to be our primary power to the motherboard. We also go from it to, in this case, to the CD. We have power plugs here that go into them. Here's one that's just kind of laying out in the open. We go down to our, if we follow this thing around, we're going to go down to the hard drives down here. We have two hard drives, and they have power plugs on them. This huge monstrous fan here, cooler, sits on top of the CPU. As we get faster and faster in the CPUs, the actual silicon gets smaller and smaller. We need more and more heat transmission. So underneath this is going to be, if you take it off, something that's not nearly as big as this thing, but we're going to have a big fan that's going to be sitting on top of a heat sink, probably a thin aluminum affair, which will help dissipate the heat. We have the two hard drives. The motherboard itself is this whole thing here. So the motherboard has screws that attach it to standoffs, little posts, metal posts that connect to the case itself. Well, we need to be sure, and there are instances where people forgot to put the standoffs in, bolted the motherboard directly to the case, and golly, when they turned it on, it didn't work so very good. It immediately shorted out. The other thing that they don't have over here, I think, we've got the optical, the power, the hard drives, the motherboard, the front of the case. Now, here we go. The memory slots. Here we have the memory slots, and these memory slots are filled. They have memory modules in them. So when you open this thing up, these are the parts of it, components that are going to initially be visible to you. Motherboard, the things we talked about, sometimes called the system board, largest and most important. And if we go back to the picture, the motherboard is the component that actually holds everything except the power supply and the hard drives. But all of the memory, the CPU, if we had a video, and this has got a lot of onboard stuff, a lot of onboard components here. These are here. We'll look at the back side of it here in a couple minutes to do this. Here we have, and while we're here, we might as well look at some other things, some capacitors, and these are here to kind of stabilize the power. If you have erratic operation of your computer, you may want to look to be sure that these capacitors are not getting old and are actually not functioning. They'll become oily and swollen, and you may have an issue with those things. So the largest and most important board, the processor, the CPU, processes the data. What computers do very well is process data. They add and subtract. They process ones and zeros. Generates the heat, requires the heat sink that we talked about, and a fan. Together these are called the processor cooler. The heat sink is metal fins that draw the heat away from the CPU itself. We're going to the back side of the motherboard. These are the on-board components. So in this one we have an eSATA component. We have 6 USB 2.0s, or where are our USBs? Okay, here we go. USB, USB, USB. A number of those, because more and more and more components are becoming are USB available. We have here a network port, an RJ45 connector. Down here we have an HDMI. Here we have a DVI port and a FireWire port over here. The blue USB 3.0s, and that may or may not be the case, but you'll notice that the USB 2 ports are black and the USB 3 ports are blue. And then here we have our 6 audio ports that allow, together in conjunction, all of these things that are connected to the motherboard allow us to connect different components to it. Expansion slots on this one, that has very few. You can kind of see them in the background. You don't really need a lot of expansion slots because almost all of the peripheral or the supporting components are part of the motherboard itself. Adapter cards provides more ports than those provided by the motherboard, the circuit board. If you need to add something, if you want to add a high-powered video card, for instance, you would need an expansion slot to do that. Most of the ports are provided by the motherboard. Most things today to be used in kind of like home or standard office use would be available on the motherboard itself. This one, memory modules, RAM, random access memory, the things that we plug in, the things that get measured. And you notice that we have, and you can't see this one, but this one would be a black slot, which would go with this one here. And then we have 2 blue slots. When you put the memory in, first you need to fill, this one's got 1 DIMM and 3 empties. We need to fill first the 2 black slots and then the 2 blue slots. In the old days, you just started and go from one end to the other. But dual inline DIMM, dual inline memory modules are the things that hold the chips, the memory chips that we use in these things. Temporary storage location. Information is read from a hard drive into RAM, and then as when we get into processors, it's read from RAM into what's called cache memory, which is faster memory, not very much, but it's much closer to the CPU. The objective is to get the information out of the hard drive, off of the hard drive, through a series of steps into the processor so that it can then take advantage of take advantage of what was on the hard drive. So we have the 3 empty slots here and 1 filled slot. When you put the memory in, you need to be sure that these little stabilizers actually snap down, and there will be a slot that they'll snap down into to be sure that the memory is seated properly. Unseated memory can cause issues. We just had a student who had to put some new memory and a couple of other things in his computer, did everything at once instead of one thing at a time, and as you modify, you should do one thing at a time. Brought it in, tried to boot, wouldn't boot, took the memory out, reseated the memory, and it worked fine. So sometimes reseating components will work to your advantage. What's inside these things? We have hard drives, solid state devices, and then an optical device. CDs and DVDs are going to look very, very similar. Process a little bit differently, but they will be there. Permanent storage is used to hold data on these things. These things are going to be called primary storage. What we call memory, the RAM itself, is going to be secondary storage. Power supply unit. converts house current, and I'm not sure I like the current term, house voltage, into usable by the machine voltage or electricity. Not real good at doing that. I'm using a mouse to try to draw those things. So that the components inside it can use it. What we do is, in our country, use 115 volts. The Europeans use 220 volts. Many of the power supplies have selectable 115 or 220 volt switches on the back. One of the things that you may see in kind of a testing world or in a troubleshooting world is somebody just brought a computer back from Europe and plugged it in and it didn't work. What's the issue? You may want to look to be sure that it's not set for 220 volts, that it is in fact, it does in fact have the 115 volts selected. The form factors are basically the shape, what it looks like. Describes the size, shape, screw hole positions, and other major features of the computer cases, power supplies, and motherboards. We need that so they'll be compatible. Many of the cases actually have multiple use. It's just a matter of where you put the standoffs in as to which type of motherboard you want to connect to them. The two form factors used in most desktops and towers are the ATX and the Mini ATX. The other kind of major standard I really didn't catch on is the BTX. The way that you can tell an ATX is that the expansion slots and the memory slots are perpendicular to each other. A BTX, the expansion slots and the memory slots are parallel to each other, which in the cooling world, the BTX, allowing airflow across with no blockage, we can get some dispersion here, probably would seem to be the better one, although it never really took off. The ATX, Advanced Technologies, the most common one, developed in 1995, has been around for a while. Open, non-proprietary industry specification. Non-proprietary is getting to be a bigger and bigger deal today. The ATX power supply has a variety of connectors, have evolved because of the new technologies. We have the 20-pin, the 20+4, and then the 24-pin. We go on and on and on as more and more and more power is needed. The following slides are common ones. We have a 20-pin P1 connector using the first ATX power supplies. Then we have a little 4-pin and 8-pin auxiliary. As the CPUs needed more power, they, instead of changing the power supply plug, added pins or added expansion power to them, used to provide an additional 12 volts of power for the evolving CPUs as they get more and more. And you notice that we talked about earlier we had 115 volts, so the power supply takes that 115 volts, and one of the voltages it converts it to is 12 volts. And then we go from the 20-pin plus the 4-pin extension, put these together, and we get the 24-pin connector, the older or the 20+4-pin P1. The older 20-pin still worked in these connectors, and it is there to support the new PCI Express slots. 6-pin and 8-pin PCIe connectors connect directly to the video card. If we use one of these video cards, because they draw an awful lot of power, and these are for high-powered video cards that you would go through. The micro ATX is a variation, reduces the total cost by reducing the number of expansion slots on the motherboard, and when you reduce the number of expansion slots, you reduce the amount of capability that it has. Reducing the power supply to the board, because if we have less capability, we need less power. It'll go into a smaller case. It uses the 24-pin P1 connector, not likely to have many extra wires or connectors or expansion slots. You may have like one expansion slot or maybe two, but very, very little. Not likely to have one on the ATX, and you may even have a situation where the power supply is external on these things as we get into these smaller and smaller things. Here's an example of one. We have the CPU slot on this one, the power supply plug the capacitors that we talked about earlier for stabilizing power, the onboard capabilities. Oops, I missed the PS2 mouse and keyboard here. You can see the serial port, VGA. We have USB ports here, RJ45 connector here for networking, and some sound. Battery here, the BIOS battery holds the BIOS settings. And on this one we have some hard drive connectors back here for serial ATA. And we also have some IDE connectors in here. Expansion slots, 2 of them on here, and then we could put external video card into this thing. Other slots, other components, and when we talked about electricity and damaging chips, things like this, if you touch them inadvertently, you can actually do damage to it. And then this one we have the memory here. And as I said before, it's an ATX because these are perpendicular. The memory is perpendicular to the expansion slots. Hard drive standards, the serial ATA used in most drives today, much faster. SATAs, parallel ATA, EIDE, IDE, a number of different things you're going to hear it called, also called an IDE. It uses a 40-pin ribbon cable. Could be an 80-pin ribbon cable. It's still going to have, or 80-wire ribbon cable, which would have extra ground wires that go with it. 2 connectors on the motherboard for the 2 data cables. We can have 2 drives per cable for a total of 4 IDE drives in a system. Uses a 4-pin power connector called a Molex connector, and you may hear those terms again. Molex is the thing that goes into these things. They're relatively difficult to plug in and unplug when you're putting one together, taking one apart. The drives themselves, and you notice the red stripe here, this is going to represent pin 1, and pin 1 will have a representation somewhere. It will be marked probably on the motherboard here somewhere as pin 1 so that you don't get these things plugged in incorrectly. You'll also notice that there is a slot here. There's going to be a notch here on the cable itself to help you be sure that you don't get it in backwards. If you get it in backwards, probably going to stop your post. The hard drive will not allow the system to boot when we do those things. But we notice here we have 2 of the PATA or EIDE connectors, and here's a close-up look of at a capacitor. But you need to be sure you get these things plugged in correctly. Hole 1.44, 3.5-inch disc holding 1.44. This would be a floppy disc that goes in here. This 34-pin twisted cable can hold up to 2 drives, and I didn't count those because that's really not an IDE. It is a floppy. The dangers of electricity, you don't want to damage the equipment. Properties of electricity, AC oscillates back and forth. This is what we get into our house, and it oscillates at 60 cycles per second or 60 hertz. Hertz is a term that you'll hear these things called. Is AC, and the direct current travels in one direction, constant voltage. This one has an average voltage. It's called a root mean square of 115 volts. Most electronic devices are going to use DC. A rectifier is a device that converts AC to DC. An inverter is a device that converts DC to AC. You may have one of those in your car. You want to use an AC component. You go buy an inverter, plug it into the battery system of the car through one of the power consoles, and we get a situation where we convert our DC to AC, and we can run the devices that we would use at home. Transformer is something that changes the ratio of the voltage to the current. What it does is called a step up or a step down, and we can take the 115 volts and convert it to 12 volt or 1.5 volts or 5 volts or whatever we need, and it will be a step down, a step up transformer. What we're really looking at in this thing is power. Let me go to this thing. The transformer power equals voltage times current. Voltage is represented by E, electromagnetic force, EI. So as the voltage goes down, the current goes up. And as the voltage goes up, I did this backwards, didn't I? The current then goes down to try to maintain power at the same level. That's why when you see power transmission in the country, we have these high volt lines, 50,000 volts, very little current. Current actually causes heat dissipation. It's the thing that does work. So the more current, the more heat, the more power. When we get into these things, power is equal to EI is also equal to, and let's see if I can do it, I squared R, where R is resistance. And this is, resistance helps us measure power. So that means that when we get into a brownout situation and the voltage goes down, current goes up, but the actual power, it goes up at the square. So a brownout situation can be pretty hazardous to your machine. We always worry about spikes, but you need to also worry about brownouts. And this one, less current, more voltage. The transformer, we get less voltage, we bring the voltage down. Let's go over here. The voltage down will bring the current up. So those things, relationship, and we're always trying to maintain power at a constant. The AC travels on the hot line from the power station, and it returns on the neutral line. When you look at your house wiring, you're going to have black lines and white lines. Green lines maybe for grounds themselves. An AC follows an unintended path, can cause a short circuit. A short circuit means it's not going where it's supposed to. It's supposed to be going this way, and all of a sudden it gets a short circuit, goes to ground. Can create an increase in temperature, sudden increase in current, which will, along with the resistance, is going to cause the increase in temperature and can destroy things. The neutral is grounded to prevent the uncontrolled electricity to short grounding, and the line is connected directly to Earth so that it can flow to Earth. When we look at these things, the neutral on this is going to be, if we look here, is going to be the larger when we look at our plugs themselves, and the hot's going to be the small one. We have these types of plugs, in the real old days, they were all the same size that could go in either direction. And then the ground plug is going to be, the one at the bottom is going to be the rounded, semi-rounded, I guess, here when we look at these things. If we only have two, we have, going back to the neutral, it's going to be the big one, and we go down here, the hot is going to be the small one if we don't have a ground on the plug itself. Disconnect the power when you work on things so that you don't get shocked or you don't cause a fire. Electrical fires, you treat or you fight with CO2. You actually unplug the device, the electrical part goes out, and then we have all the insulation burning. Since we don't want to destroy the electronics with caustic chemicals, we use CO2 to actually cool the thing to stop the insulation from burning. When you're working on electrical devices, when I first learned to work on them, they made us take all of our jewelry off, everything metal off, makes sense, and work on it with one hand behind your back. Because if you will hold your hands out, if you create a path across your body, there's a pretty important part called the heart that the electricity would go through. And just in round numbers, electricity, if you remember, we talked about 60 cycles per second, 60 hertz. It will try to make your heart be at that rate because it's going to be changing from highs to lows at that rate. And hearts really don't work very well at 60 hertz. So you probably want to use the one-hand rule if at all possible, absolutely possible. Then when I was working on those, we were going to radars, things like that, were higher powered. Potential dangers, and these are all real dangers. A cord is frayed or damaged, water or other liquid is spilled, device is dropped or physically damaged, small electronics odor, and that's something that's not describable, but once you smell it, you'll know what it is. Power supply fans make a whining noise, smoke coming from and the case feels unusually warm. Back to the power cords frayed or damaged. You also should feel these things occasionally to be sure that they're not getting red hot. If they're getting too hot, you need a bigger power cord or a bigger cord to carry that amount of burn. Processor, ground yourself with an anti-static bracelet connected to ground, and ground would be the case itself. It doesn't really matter what the potential is or what the voltage is, as long as you and the components are at the same potential, so that when you reach across, you're not creating that static electricity as you go through those things. Power supplies, printers, and CRTs that contain capacitors, don't ground yourself because the power can flow through. Capacitors store electricity. They can store electricity for a long time. CRT monitors, if you've ever been bit by one, it hurts. You need to ground these things to discharge them before you work on them. Hopefully you'll not see many or any CRT monitors. Basically, you're not going to be able to do a whole lot with them, but they contain high voltage capacitors that can do serious damage to you. Power supplies, field replaceable units, which means that we're not going to open it up and make any changes to it. In the days past, they sometimes had a fuse in them that could be replaced, but I think that if they don't reset themselves now, you're just going to have to replace it. They're not an expensive component, something that is relatively easy to replace, 4 screws, and then unplug and plug everything back in. Don't use the water. It's a conductor. Use the fire extinguisher ready to put out electrical fires, typically going to be CO2. The type of fires, we have Class A, can use water. Class A is going to be wood, paper, and other combustibles, and the way that we recognize these is it has white smoke. White smoke. Can't do that very well, can I? And Class B fires caused by liquids such as gasoline, kerosene, oil, petroleum products, and these are going to have black smoke. Black smoke. I'm not going to try smoke. Class C, non-conductive chemicals to put out these fires caused by electricity. And if you have smoke, you're going to have sparking and smelling. If you have smoke, it's going to be whatever color that the insulation creates. Dry chemical fire extinguishers. You need to have fire extinguishers available. We've had an incident where an instructor put out a fire in a computer, and the way she put out the fire in the computer was simply by unplugging it. This one, classification, A, B, and C, is a Class C here, colon C, that we can use this particular one on. Electrostatic discharge, electrical charge at rest with static electricity is what we're really talking about here. Two objects with similar electric charges touch. Electricity passes between them and walk across carpet in the winter when the relative humidity is very low. Touch a metal doorknob and you get a shock. We can get those shocks and shock our computers relatively easily and not even feel it in many cases. Two types of damage: a catastrophic failure, which destroys the component on the spot. The thing that is probably more worse, but more difficult to troubleshoot, is the upset failure. Damages the component so it doesn't work well. The damage continues to materialize, and eventually it may fail or it may just get to where it does not work. But each of these permanently affect the device. To protect against ESD, we notice that we have EDS here as ESD, Windows or Word helped out in this one, or PowerPoint when they did this. Ground yourself with one or more of the ground bracelet, ground mats, or there are ankle bracelets. If you don't have one of these, touch your skin to the metal case before you start working on it to equalize and keep your skin, your forearm, on the case as you work on the system itself. Static shielding bags, anti-static bags, components are come into those. Store the components in the anti-static bags. Anti-static gloves are also available to work on the devices with them. Rule 1, passing a circuit board from one to the person to the other, ground yourself and touch the other person before you pass it so that you're at the same electrical potential. Leave the computers inside the anti-static bags. Work on hardwood floors and not carpet because you have less capability to produce the static. Carpet is going to help you with the static making it. Don't work on the computer in a cold, dry atmosphere because you're not going to have a high relative humidity. One of the things that I read years ago to help you with this, if you will mix a little bit of fabric softener, liquid fabric softener, with water and put it in a spray bottle and spray the area before you start, you'll reduce your capability or your probability of producing static. Remove the packing tape and cellophane from around the work area because they attract ESD, and keep the components away from hair and clothing. Essential tools: a ground bracelet, ground mat, anti-static gloves, a flathead screwdriver, Phillips screwdriver, Torx screwdriver. You may or may not need the Torx. We went through that for a while. Older systems, you may need them. A lot of the newer systems, you don't even need a screwdriver to get them apart. They are quick releasing, which is good and bad in a corporate environment. Not necessarily real good because it allows people to open the cases relatively easily. Insulated tweezers to get to the small parts. An extractor is what used to be called a chip puller, something that helps you remove things. And the operating system recovery CDs or DVDs, and in many cases you have to make your own recovery CD when you buy the systems. Other non-essential tools, toolbox itself. This is kind of some of the things you're going to need. Flashlight, and it wasn't on the list, but a flashlight to me is something that's very important because it's difficult to see into these things frequently. This is going to be a cable tester, an RJ45, and a coax cable tester here. The CD recovery CD, or maybe troubleshooting CDs. In today's case, you're probably going to have a troubleshooting USB drive instead of that. We have a postcards here, things to check the system with: the screwdrivers, extractor here, tweezers, and screwdrivers. These, when you press this, opens up and you can actually use it to start screws or pick up screws in small places. The anti-static gloves, the anti-static bags, a wrist strap here, a can of air to blow out dirt. You don't really want to vacuum out machines. You want to blow it out with these types of air. You don't want to use an air compressor because it may have oil or water in it, which can do damage to the system. You can use this little plug. You can usually get these at a hardware store to test to be sure that the outlets in the house or the outlets in the business are actually installed correctly, and you have the hot and the neutral and the ground wires installed correctly. A multimeter that we can use, and we'll talk about it in power supplies, to check the power supply voltages. These straps here, nylon straps, in order to put together the wires to get them out of the way so that you don't interrupt the airflow across the machine. Cups here, little cups, are handy when you take them apart to put the screws in so that they don't go all over the place and you put it down, you don't know where you put it. So something to hold the screws with. This one's a diagnostic postcard, discover and report computer errors, post power on self-test. And it will give you errors here, and you can look up the error code and it'll tell you exactly what's wrong with the machine, why it didn't get past post. Okay, three purposes: motherboard, ROM, BIOS. The system BIOS manages the simple devices. The startup BIOS starts the computer, and the BIOS setup changes the motherboard settings. The battery that we talked about earlier holds those BIOS settings, the things that we configure. If they go away, you may want to look at the BIOS battery, although BIOS batteries will last, typically in today's world, are going to last longer than the machine itself. CMOS RAM, random access memory, the date, time, port configurations. Flash ROM down here, ROM chips that can be overwritten, which has always been kind of an anomaly to me. ROM is read-only memory, and now we have ROM chips that can be overwritten. EEPROMs, electrically erasable, programmable, read-only memory. In the good old days, you could only do these things with a special ROM writer. In today's world, we can flash the BIOS, make modifications to it simply by downloading the information and put it on some sort of a bootable device and changing the firmware. Keep in mind that if you do this, if you have a power interruption during this, you may make yourself a nice doorstop. Power supply tester. To test the power supply itself, this one's out here. We have the on-off switch and the on-off switch and the plug in. The selectable that we talked about earlier right here, 110 to 220, 115, 220 volt selectable. The fan should always be running. This, in most cases, the thing is going to draw the air across the motherboard, across the components, and bring it out of the case itself. The power supply tester is going to test, and we have notice here the 20 plus 4 pin, so this is going to be a 24 pin connector. It's going to test the power supply output voltage. It's going to load test the power supply. If the power supply is not loaded, it may produce the correct voltages, and then when you try to actually do work with it, it's not producing sufficient voltage, sufficient power. Multimeter to measure characteristics of electricity. You can measure voltage, you can measure current, you can measure resistance with these things. The little ohm sign here, when we select it, it's going to be resistance, AC voltage, and DC voltage. And if we put it in line, we should be able to check current with it. Loopback plugs basically go out the computer, around, and back in. What it does is just checks to be sure that the internal component is working, and also can check the wiring, can check a number of things. Most cleaning solutions contain flammable, poisonous materials. Don't use them. MSDS sheets, material safety data sheets, explain how to properly handle substances. May require an accident report if an accident occurs in using dangerous products. What you don't want to do is use them. The outside of the case, plain water can be used to wipe down the cases themselves. Internally, you don't want to really use any sort of solution, cleaning solution. You want to blow it out with air. Some things that can be used: solutions and pads, multi-surface cleaners, contact cleaners, head cleaners, monitor wipes, different things that are available that are safe to use with these things. Cables can be a real issue as they go from place to place, and then regardless, I think, of how hard you try, people are going to make an effort or maybe not make an effort, but they may become an issue if left on the floor. This goes back to, like, slide 1 or 2, what kind of machinery you're going to buy. If you buy the one piece and set it on the desktop, you're really not going to have anything but maybe a power cable and a network cable that goes to it, and if you use wireless, you wouldn't even have the network cable. If you use towers of any size and set them on the floor, you may have a wire hazard. You need to put those things together, and that's what the nylon ties would be used for, is to group the wires, put the wires in such a manner that they don't become a trip hazard. Use a cable or a cord cover. You can do that. Maybe not necessarily the prettiest thing in the world, but it's going to be effective in helping with the trip, and so that people, when they roll across it, are not crushing your cables. Lifting heavy objects, stand close, and many of the jobs, probably most or all the jobs that you go to, are going to have a lifting requirement of 50 pounds. Which side of the object is the heaviest so that you can balance it? Close to the object, keep your feet apart, back straight. What you're going to do, you want to lift with your legs, arms and shoulders, not your back or stomach. And keep the load close to your body, avoiding twisting. If you've ever done this with your back and hurt your back, you know that you don't really want to do that again. So the first look, we looked at some ports that are available, USB, FireWire, eSATA. When you take the A+, they're going to expect you to identify a number of these components. What's actually inside the computer, and as we go through this course, we'll look at each of those modules, and we'll talk about those things: the processor, expansion cards, the DIMM modules, the hard drives, optical drives, floppy you may or may not see, tape, and power supply. Form factors on these things: the ATX, the micro ATX, and the mini ATX are the ones that are the most popular today. The BTX kind of just didn't make it. Power connectors, we start out with the 20-pin, and then we have the 20-pin plus 4, the 24-pin, and we have a 4 and an 8-pin auxiliary pins on the motherboard. The 4-pin Molex is used in the IDE or pay-to-parallel ATA drives. 15-pin serial ATA, 4-pin floppy disk drive, and these are power cords. A 6-pin PCIe and the 8-pin PCIe to connect these things together. Standards are used by hard drives and other drives. Standards are important because they allow multiple manufacturers to make components that will work in the computer itself. And if you think about pricing of things, a PC is typically going to be much less than a Mac. Mac, a great machine, but it's proprietary. Apple makes everything. You can't go to a store and buy a kit. Well, go buy a Mac motherboard and this video card and that wireless or whatever else. You have to buy everything from Apple. PCs, we have standards that allow, again, different manufacturers to manufacture the components, which is going to create competition. Competition typically reduces the price. One of the reasons that they cost less. Hard drives and other devices, power supply that are serial ATA and parallel. We have to have the motherboard, the power supply, everything has to fit for these things to work, and that's where standards come in for us. Units used to measure electricity include volts, amps, ohms, joules. We didn't talk about joules and watts. Volts, the voltage itself, the amps, the power for the current, ohms for resistance, watts for power. When we multiply voltage times current, we're going to get volt amps or watts when we do those things. Computers use DC, which is converted from AC by the power supply, by the PC's power supply. AC, DC. AC, constantly changing, 60 hertz, 60 cycles per second, and you don't want to get that across your body. DC is a constant voltage, and the power supply converts those things using a rectifier to convert the AC to DC. Power supply and CRT contain dangerous charges. CRTs, hopefully you won't see. Cathode ray tubes. These can be really hazardous because they have very, very high voltages when you do this. Power supply, if you're going to work on a power supply, don't just change it. Take the 4 screws out, take the power supply out, unplug everything, put the new power supply in, and move on. You may want to use a power supply tester to prove that it is bad before you actually change this thing. Don't use water on an electrical fire because water is a conductor, will create many short circuits, which will just make your fire worse. Protect the ESD, we're going to use the ground bracelet or ground mat, anesthetic bags, anesthetic gloves, everything that we can possibly do to put our body at the same charge as the devices themselves. Special tools, a postcard, which will tell, postcard, not the thing that you send, but power on self-test card. It's a diagnostic card which will tell you exactly what's wrong, why the system isn't getting through the initial tests. Post is a thing that does some initial basic tests of the computer when you turn it on before it gets to the operating system. It checks, for instance, to be sure that there's memory, video, and that the powers are correct. Typically, you'll get a single beep or no beep. If you get multiple beeps, the system will also tell you through a Morse code beep system what's wrong with it. Power supply tester, multimeter, loopback plugs may also be used to do these things. MSDS, how to handle the chemicals. And we really don't want to use chemicals around these things if we can all avoid it. And then the lifting, lift with your legs and not your back, because back problems can be very, very lingering when you go through this thing. Be sure your cables aren't a trip hazard, and actually crush hazard as well as a trip hazard. People trip on them, they're going to dislodge them, it can do damage to the ports as well as the cable and the individual themselves if they should happen to fall. With that, I would like to thank you for watching.